yourself. Your background noise might create a problem for the presenters. And secondly, please don't start your presentation mode, because if you start your presentation mode, the PPTs or the presentations showing by the speaker will go off and he has to turn it on again manually, and it will create some problem and it will lose out some amount of time. So please follow these instructions and cooperate us for the smooth conduction of this program. Thank you. Okay, it's time to start. Good morning, all of you, and welcome back to the second and final day of the 2-day-long international webinar on recent trends in nanomaterials and nanobiomaterials, in short called RTNN, organized by the Department of Physics of our college. Yesterday, we could witness some excellent talks from the eminent speakers around the world who were the invited speakers. So, throughout this 2-day, we have all total 6 invited speakers, out of which 4 had presented yesterday, which you could witness today. There will be 2 such talks by Dr. Sudipto Pal from University of Salento, Italy, and followed by Dr. Narajole from Jeonbuk National University, Republic of Korea. We also had some paper presenters throughout this 2 days. There were total 13 paper presenters, out of which the first 3 presented yesterday, which we could see yesterday, and the rest 10 will be presenting today. So without wasting any time, I'll directly go to the formal procedures of today's program by the discussions on the topic. Our first presenter will be Dr. Sudipto Pal. He is currently a scientist from the Department of Innovation Engineering, University of Salento, Italy. Dr. Pal has done his master's from Parua University, West Bengal, following which he has done a PhD from the CGCRI, Kolkata, India. After that, he had been a postdoctoral fellow for 1 year in the University of Brescia, Italy. Dr. Pal has research journals of more than 27, and he has immense amount of research and job experience for more than 10 years. Today, Dr. Pal is going to talk about nanomaterials in environmental remediation, self-cleaning, and antimicrobial surfaces, from laboratory concept to practical applications. So, ladies and gentlemen, please welcome Dr. Pal. Sir, you can start your presentation.
Okay. Hello, good morning to everybody. Just can you hear? Can you see the screen? Hello.
Not yet, sir. You have to share the screen.
Okay.
Go to the presentation mode, present now, and select your window.
Yes. Okay. Can you Can you see it now?
Not yet, sir.
Because
Yeah,
I have.
it's coming. I guess we have to wait for a while.
Okay.
Yeah. Yes, we can see it now, sir.
Okay. So today my talk is about the application of the nanomaterials on the environmental remediation and self-cleaning and antimicrobial surfaces. And I will show some direct application from laboratory to the practical field. Uh, and in my talk, I will divide it into two parts. One is the environmental remediation and self-cleaning effect, which is mainly on photocatalysis of titanium dioxide. I don't know whether you know about the titanium dioxide, which is known as TiO2, and it is the most widely used photocatalysis in the world. And another one is the application in nanobiotechnology, which I will talk about the antimicrobial surfaces, mainly on silver and copper nanoparticles. Now, what is photocatalysis? It is a phenomenon where the acceleration of a chemical reaction takes place in the presence of light source and a catalyst. And here the catalyst would be the TiO2. And the process is similar to the is similar to the photosynthesis, where in the tree leaves the chlorophyll absorbs the light and CO2, and it converts converts into oxygens. So similarly, one photocatalyst, it absorbs the light like sunlight or other source of light, and then it reacts with the environment or in a chemical reaction, which converts the chemical contaminants into CO2 and water. Like I will show you in the next slide. This process was first discovered in Japan by Honda and Fujishima, where they showed that with the use of TiO2, they can they can split the water to oxygen and hydrogen without using any voltage. So they did this experiment to show that the TiO2 could be used as a photocatalyst. And what is the mechanism? Here you can see on the right image, on the right corner in the bottom, then there is one phase diagram of TiO2, where if one light like artificial light or sunlight falls on one TiO2 atom or molecule, then the the electrons goes from the valence band to conduction band, and so one hole is left in the valence band, and this hole can interact with water to produce one hydroxyl radical, and the electron in the conduction band, it can produce the superoxide anions. So these two radicals, they can.
Sir, just I'm sorry. Someone has
Yes,
intervened. Mr. Gopal Pal, you have started presenting. Please switch off your or stop presenting. Mr. Gopal Pal, I'm requesting you to please switch off your. Thank you, sir. Sir, you have to turn on the presentation mode once again.
Okay, but it is okay. Next one. Is it okay now?
Yeah. Sir.
Okay, so actually, this is the mechanism of the photocatalysis, and I have just showed one example with TiO2. there are several other photocatalysts in the market, and why we why I tell about the TIOT, because it's an excellent photocatalytic. It has excellent photocatalytic activity, and the photo activity at ambient condition can be done. It has long-term photo stability, and this point is one of the most important, because if one photocatalyst degrades by one reaction, after one reaction, or two reaction, then it is of no use. So the TiO2 is used mainly due to its long-term photostability and productivity, and it is mainly inert in many chemical environment, and it is non-toxic, and in the world it has huge availability in commercial sites, and is comparatively cheaper. And the major applications of TiO2 is mainly in the coatings, like in common household appliances, in the cars, in cosmetics, like in like personal care, I mean sunscreen and other creams, in shoes, in different paints, even in the paper industries, and in toiletries, like the white coating. And the main photocatalytic mechanism of TiO2, as I told in the last slide, that when one light falls on the on TiO2. Hello.
লিংক দেওয়া আছে, আপনি গুগল লিংক পাননি কেন পাননি? ওয়েবিনারে জয়েন করেননি আপনি? ওয়েবিনার আনলক করেছিলেন তো? I guess your microphone is on. Runda, kindly mute yourself. Yeah, sir, please continue.
Okay. So as I told in the last slide, that the main mechanism is when the light falls on TiO2, it produces the hydroxyl radicals and superoxide anions. And on the right table, you can see the oxidation potential of hydroxyl radicals and other radicals. Actually, it is the similar process when we use like some bleaching or anything to oxidize or to decolorize the other, like the pollutants and color, and it is the similar process. But here there is no need to use any harmful chemicals or other substance, because only with light you can eliminate any contamination or any pollutants. But one major problem is to produce these nanomaterials. But in our laboratory, we have produced this material in large scale, mainly in industrial scale, by one method. It's called hydrothermal and spray dyeing. So what we do, we take one precursor of TiO2 and then make it soluble in water, and with hydrothermal treatment, it can be converted from amorphous to crystalline, and then make it spray dyeing. So what is spray dyeing? Also, the next slide. This is the setup of spray dyeing, where in the bottom the TiO2 sol is left, and then it is sprayed with one atomizer, and with the air pressure it forms the droplets, and it forms a spherical spheres. But why we need this kind of spheres? Because the size of any nanoparticles is usually less than less than some micron, and even it can goes up to 10 to 20 nanometers. But if we use this at this size, it is very dangerous to the environment, because it is very hard to collect after the reaction. So if we use the same material with higher amount of volume, so it can be collected easily after the reaction. So for this reason, we have used this kind of microspheres in the environmental remediation. And there are some images which shows the perfect spherical shape of these particles, and they are highly crystalline, so they can be used in a real field. But after the reaction, we can collect easily as the size is much more higher. And to know the photocatalysis, whether it is working or not, in the laboratory scale, we are using some kind of stains like dyes, which is widely used in the clothes industry. So so in clothes industry, this kind of material is very dangerous to the environment, because after the some excess amount of dyes, it is the industry, they release to the environment, and it is very unhealthy, like it is very carcinogenic. So this pollutant we used as a model pollutant to be degraded with TiO2. So what we do, we take some of this pollutant and then mixed with some amount of the photocatalyst, and under the solar light, like one simulated solar lamp, we steer and we observe the absorption spectra of this material, so that we can understand at what time it can be degraded. And another application is the NOx degradation and self-cleaning. So what is the resources of NOx? It is mainly it is mainly the emission from the industries, and the emission from the cars and other vehicles, and from the thermoelectric power supplies. And why it is more dangerous? Because it has many adverse effect on the environment, like it is very carcinogenic. It can make the fogs in the environment, and some other issues like smokes. And here I will show in some setup where in the laboratory scale we can check that with the use of the use of a photocatalyst, we can see whether it is working to degrade the NOx or not. And in the first slide, you can see the NOx is a combination of nitrogen oxide and nitrogen dioxide. So in this setup, usually we feed from some cylinder of NO2 and NO, and with the combination of air, it is feed into the this glass vessel, and with the gas chromatograph we can monitor whether it is it degrades or not. And with this setup, we can see whether one photocatalyst is working or not to degrade the NOx. And this image shows some of the pavement tiles which is coated with TiO2. So what happens if some polyp, some impurity or some pollutant get in touch with this kind of TiO2 coated tiles, then on the then with the help of the sunlight, it degrades into
Sir,
CO2.
sorry, your presentation mode has gone off again. You have to start it.
Sorry, hello.
Your presentation mode has gone off. Actually, someone again tried to switch on his presentation mode, so your mode has gone off.
Okay.
Sorry about that.
No problem. Okay, now.
Yeah, it's fine, sir.
Okay, so if some pollutant comes in contact with the TiO2 coated tiles, so what the TiO2 nanoparticles they do with the help of the sunlight, they just degrade the pollutant into CO2 and other component, and when the rain comes, it washes out the pollutant. So there is no need for any external source or external chemicals to wash out the pollutants like darts or some dust or some other organic pollutants. So so it is automatically cleans the surface, and that's why it is called self cleaning surfaces. And the self cleaning activity in the same way, so if one if on TiO2 coated surface some UV light falls on it, then the contact angle suddenly decreased near about to below 20 degree. So if we coat some TiO2 on glass window or the walls, then what happens with the effect of the sunlight, if some organic contaminants or some dust particles or some other stains falls on the surface, then the TiO2 with the help of the light, it degrades the pollutant into CO2 and H2O. So when the rain falls, the rain washes out these kind of stains or dust or other organic pollutants. So again here, there is no need for any external source to clean the surface, and it is very extremely useful in case of high-rise buildings and other commercial sites. And here you can see the activity, how it works. If the TiO2 convert the contaminants or any stains or any colors or any darts into CO2 and water, then when the water falls on the coated surface, then it washes out the contaminant. And in the right image, you can see that. And this is one image of one big solar cells, where if the solar cell is coated with these TiO2 nanomaterials, then with the help of the sunlight and water, it automatically cleans the surface. So if we have a large amount of this kind of solar panels, and if we coat with the TiO2, then there is no need to clean this surface every day or every time, because if the solar panels are covered by the dust or other organic pollutant or some stains, then the efficiency will be highly decreased. So to work it properly, nowadays it is being coated with some anti, like some self cleaning coating. And the other application in the big architectural buildings, where it is coated with the TiO2, and in this case the TiO2 powders are mixed with the cementitious materials, and then it is applied on the outer surface, as well as it can be also used in the inner surfaces. And another application of this, on the right image, you can see one mesh like structure. This structure is made with the TiO2 coating, and if they are coated near any signaling, because if near the signal, the pollution rate is very high. So again, with the help of the sunlight, it can decompose the NOx or other volatile compound or other gases to clean the environment. And in the bottom image, again, it is the example of the pavement which is coated with TiO2. Another example is to clean the water. So with the same photocatalysis technology, we can use we can use any decontaminated water to clean it. So how to do it? To do this, you can see one sponge-like material. It is one ceramic filter which is coated with TiO2. So the contaminated water passes through this kind of filter, and again with the help of any light source like either UV light or any solar light, the photocatalysis takes place, and the decontaminated water is transformed into clean water. Another application of the photocatalysis is to decompose ethylene. Now, what is ethylene? Ethylene is a natural ripening hormone. Actually, we use to deepen some unripened fruits and vegetables. But in the food storage, like in cold storage or some food storage container, if very low amount of ethylene is produced, then it can ripen the fruits or vegetable very fast. So within very few time, all the vegetables or fruits which is stored in a specific container, they can be spoiled. And every day in the world, there are huge amount of these the fruits or vegetables are wasted due to the high ripening rate of this with the presence of ethylene. So if we remove the ethylene from the storage container or in any storage building, then we can contain or we can retain the fruits or vegetables for a long time. And how to control the ethylene emission? And usually there are two natural ways. One is the low temperature storage. Like if we keep one fruit or vegetable in the fridge, then it can long last than if we store at ambient. So and other is high relative humidity, like 85 to 95%. But in this two mode, if some ethylene is generated, they cannot be removed. They can contain inside the environment, and then they can accelerate the ripening of fruits or vegetables. So if we control this ethylene and we degrade by means of photocatalytic way, then the fruits or vegetables, they can be stored for a long time. In our laboratory setup, we control whether one photocatalyst is working or not. So in a photocatalytic chamber, we insert some specific amount of ethylene, and we put one photocatalyst, like in the form of powder. It can be in the form of powder or in form of any coated substrate. And with the gas chromatograph, we can see with time that whether the concentration of ethylene is decreasing or not. So from this kind of experimentation, we can control whether one photocatalyst is working or not to decompose the ethylene. And this image shows one real-time photocatalytic measurement with some tomatoes. On the right side, on the top right, the on green tomato is treated with with ethylene. So at a certain time, say in 7 days, it it is fully depend. And if we use the photocatalyst on the middle image, the green tomato still they are somehow green, so it takes longer time to depend. That means it can decompose the ethylene with the help of the photocatalyst. And with the control experiment, I mean without the photocatalyst, it also depends very fast. So if we make one loop where the inside air where the fruits or vegetables are stored, it can circulate through one photocatalyst and one in presence of the light. So it can be, so the ethylene inside the container can be removed, and the fruits and vegetables can be stored for a long time. Now I move to the nanobiotechnological section, where I will show the activity of anti-bacterial or antimicrobial surface. Usually, copper and silver is very popular and is known from long time for their antibacterial activity. But to have the practical application, they need to be coated or to be functionalized with some other substrate, like any surface or clothes or any other material. So here, what we did, we have coated the cellulose substrate because we have coated the cellulose substrate with the silver, and it is mainly the silver nanoparticles. So why we choose the cellulose? Because it is the common substrate, like we can like our clothes or any everyday use substrates are made of cellulose. So if we see in the image, on the left image, we did the experimentation with the help of one bacteria, it's called E. coli. On the left image, it is the only cellulose substrate. On the right side, it is the cellulose substrate with silver. On the if we see in the image on the right side, the silver containing cellulose, where the bacteria has not been grown, and on the left, if we use the only cellulose substrate, the bacteria has grown. So it shows that if we coat any textile or any surface with the silver, so it can repel the bacteria. And another is copper nanoparticles. So either silver or copper, they can be coated with some specific method onto, like some polymer fibers, some cotton fibers, latex and everything, and other substrate. And some applications like to make antiviral filters, antibacterial filters, antifungal socks, and mattress and other substrates. Another application is you know that now there is the fear of the coronavirus. So with the help of this kind of textiles, the coronavirus also can be killed, and we are also working on this. Either silver or copper can be coated on the threads, like which is used to make the clothes. And here is one image where So one company is using the copper coated textiles to make the hospital beddings. And so after, so with, I mean, by using these types of textiles, it has the very high antibacterial activity. So if some patient with some kind of infections, they come into contact, then they can be killed automatically with this kind of clothes. And another very recent application of
Sir, excuse me, sir. Sorry for the interruption. Actually, we are lots of talks are coming up, so actually we don't have much time.
yes. I'm just going to finish. Okay.
Yeah, sure, sir.
Okay. So another very recent application of copper is like in wound dressing and in the facial mask. So especially on the facial mask, if we coat the mask with copper or silver, then if the virus like coronavirus, it comes into contact with the filter, then it can be killed automatically. So the spreading could be automatically, would be stopped very effectively. And another interesting application of the combination of the photocatalysis and the antibacterial activity. So there are some companies who are producing this kind of air purifier, where they use the both technology to purify the air, and it is mainly used in some indoor applications like a house or hospitals or in the offices. So in conclusion, what we can see, the photocatalysis using the nanomaterials like TiO2 could be very effective for the environmental remediation, and the antibacterial nanotechnology could be used to fight against the germs, bacteria, and viruses. And the combined technology could be very effective in indoor air purifications, like in the hospitals or in offices or some other places. Okay, so with this we can stop. Okay. So thank you for listening to my talk.
Thank you, Dr. Pal, for such a wonderful presentations of yours. Unfortunately, due to shortage of time, we can't have any question answer session. So I'd like to request all the audience to please contact Dr. Pal through his email ID and to clarify your any doubts if it comes up in future. Thank you. We'll carry on from here. So, sir, you have to stop your presentation.
Okay. Okay. No.
Yeah. Thank you, sir. So our next talk will be again on the discussion of topic, and this will be the last invited lecture by Dr. Haradhan Kole. Dr. Kole is currently a postdoctoral fellow in Department of Housing, Environmental Design and Research, Jeonbuk International University, South Korea. Dr. Kole has done his master's from Annamalai University, Tamil Nadu, India, followed by a PhD in Vidyasagar University. He had been a postdoctoral fellow for 1 year in Department of BI in Convergence Technology, again Jeonbuk University, Republic of Korea. Dr. Kole has published 28 very prestigious research journals. He is working in the project for development of wood properties by chemical treatment and improvement of housing environment and development of polymeric materials for various usages. He has also been the peer reviewer in many prestigious journals. And today, in front of all of you, he is going to talk about metal nanostructures for wastewater purifications. So, ladies and gentlemen, please welcome Dr. Haradhan Kole. Sir,
thank you. Thank you. Can you listen to me?
Yes, sir, we can listen to you.
Okay, I'm going to share the slide. Could you see the screen?
Yes, sir, we can see that. Please, you can start.
Okay. Good morning, everyone. Now, welcome to this international conference entitled Recent Trends in Nanomaterials and Nanobiomaterials. I would like to focus on the title Metal Nanostructure for Wastewater Purification. I will try to cover in my lecture introduction, bio-inspired synthesis of metal nanoparticles, nanostructure for wastewater treatment, nanostructure for detection of toxic metal ion, and conclusion and the future scope. First of all, I would like to address your presence. Please kindly give the patience up to last slide. This introduction isn't a very eminent part of the research. Suppose you want to design any research scheme, that time you have to go first to background research. And after all, background research study, you can design a scheme and then you can process your experimental part. And after all, you will discuss your outputs in a manuscript, and then you can publish it in journal and it will be a scientific report of it. So introduction part, all of the paper is very important. Now I am going to discuss about the nanostructure components. It is well known that the nanostructure components would be in between 1 nanometer to 100 nanometer. If I want to say that 1 meter is equal to 1 billion nanometer, and it's also to be more clear, and if we think the average width of the human hair is on the order of 10 to the power 9, 10 to the power 5 nanometers. And this is the size of the nanoparticles. And next interesting point is that surface area of the nanoparticle. And it is already reported and already discussed by the other speakers also, I hope, that surface area about the nanomaterials. Already all are predicted about this, that the nanomaterials have the high surface area. According to this high surface area, the interaction of the other component will be more, and that's why we are interested to synthesize the nanomaterials. And I have reviewed so many papers. According to this experience, I want to share my knowledge. The authors already try to report and that the nanomaterials have this high surface area. That's why it's become this get this more active, and that's why they are finishing this explanation. But I would suggest that surface area not only depends on the size or shape, it is dependent on the porosity of the materials also. So when you will like to focus on the surface area, I will suggest you will address the specific surface area. It's nothing about it. It is the per gram surface area of the material, and you can measure it easily with the using of BET analyzer, and you can get this specific surface area. And I also focus on this material. Why I want to address the porosity. Suppose this is the spherical structure of the material, and if it is in porous, that time you see there is so many nanowires like porosity, and it's the more surface area than this material. In my next slide, I would like to focus these types of nanomaterials. There are 4 types of nanomaterials. There is 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional. What is this dimensional? And according to this, dimensional means in 3 axes, X, Y, and Z axis, all dimension is the nanoscale. It should be in 1 nanometer to 100 nanometer. What will be the 1-dimensional material? The 1-dimensional material is to be only 2 dimension is in nanoscale. Suppose X, Y axis is in nanoscale and Z axis is out of nanoscale. So it should be a 1-dimensional. What will be the 2-dimensional? The 2-dimensional will be only 1 dimension is in nanoscale, and other rest of the 2 axes, X, Y, or Z, whatever, so and there will be out of the nanoscale range, 1 nanometer to 100 nanometer. And 3-dimensional scale, there is no dimension in nanoscale range. That is, if we share the examples, that time it will be the quantum dot nanoparticles is the 0-dimensional. 1-dimensional should be in nanowires, nanorods, and 2-dimensional material will be nanofilms and nanocoating, and 3-dimensional is the nanopowder, powder solid or solid state material. Next, it is already discussed by the speaker earlier, I hope so, because it is the synthesis process of nanostructured material. There are only 2 types of synthesis approach to synthesize nanomaterial, top-down approach and bottom-up approach. Top-down approach always starting with the material in solid state, and bottom-up approach most of all in gaseous or in liquid state. Most of the uses is in liquid state. So if we want to make you more clear about this 2-dimensional approach, I want to use an example. Suppose you have to prepare, you have to design or draw or prepare a Krishna idol. Suppose you are going to prepare a Krishna idol, and you form a stone, big stone. That time what you will do? You will design this Krishna idol according to your pencil and some things here, and you will cutting it or etching it or grinding some parts and something. So then you will get the structure of the Krishna idol. It is the process of top-down approach. It will go through this bottom-up approach. That time, suppose there is so many like cement, powder material, and then you will mix with water and you will make the cluster materials, and after using the cluster material you will finish the Krishna idol. So this is the main difference between the top-down approach and bottom-up approach. Bottom-up approach, there is then physical techniques. You can use it by PVD, and the chemical techniques by CVD. This is chemical vapor deposition, and PVD, physical vapor deposition. And next slide, what will the more advantageous? I will always suggest the most advantageous process is bottom-up approach, and you can design here according to the materials, and you can design the nanomaterial structures also. Nano aero size distribution is possible, and this advantage is only the large scale production is difficult, because it is well known about the nanomaterials that we cannot resynthesize the same size of the nanomaterials in ever. So it is the main drawback of the nanomaterials field. And then I am going to discuss about the color of different nanomaterials. And it is well known that if we synthesize the different particle size, that time we will get the different color intensity. If it is 60 nanometer and it is 50 nanometer size of the particle, that the color difference is so much. It is very clear to all of you. And it is the gold nanoparticle and it is the silver nanoparticle. If we use the combined between the silver and gold, that time we will get this type of color according to this bimetallic nanoparticle. And this is the already, and wet chemical process. Mainly, if we design the wet chemical process for the synthesis of the nanomaterials, we have to take the metal ion solution and reducing agent and stabilizing agent. Then biological synthesis of nanomaterials. To design, in previous slide, I have already addressed the reducing agent. It may be so many chemicals you can use for reducing agents, sodium borohydride, hydrogen hydrate, so many, there is so many reported. And stabilizing agents is the surfactant you can use or any polymer. I would like to address this, biological synthesis of nanomaterials, because we want to reduce the use of the chemicals, and we want to use the sustainable development of our environment. That's why I would like to address the biological synthesis procedure. By using the biological synthesis procedure, we can synthesize the biological nanoparticles using the proteins, amino acids, vitamins, polysaccharides, polyphenol, terpenoids, organic acids. I have already found that Dr. Camilla already doing some types of research using this type of biomaterials and protein substances. And these fungus. You can use the fungus enzymes and nanoquinons, anthraquinons, whatsoever. And then I am going to my work. I would like to focus on this particular area, that I have synthesized the nanomaterials using a mango flower extract. Silver nanomaterials, I using the mango flower extract. Just collect from the mango flower. You can collect it bottom of the tree. It's already waste material that is collected, and after all you clean this flower, and then you can make a extract. And using this extract, simply you take the sample solution and you just put drop this mango flower extract, and you will get this silver nanoparticles easily. And it's already published in Composite Part B Engineering Research 2019. And after the synthesis process, we are aware about it, that we have to characterize the materials, and we can use this different kinds of extensive characterization techniques, that is the X-ray diffraction. And there is so many reported. I already highlighted this type of techniques that we are always doing this, using these techniques we can predict the nanomaterial characterization. And these are the systems characterizations. And characterizations of silver nanomaterial, I have used this UV. This is the UV visible spectroscopy. This is the spectra, and you see this mango flower extract, and this is the silver nanoparticle, and there is an lambda max value 4 to 8, which is in the range of the nanoparticles. And this is the XRD report, and these are the FTIR. According to this FTIR, XRD, and the UV, preliminarily confirm that there is the synthesized and nanomaterials or nanoparticles. And after this TEM spectra, TEM image, and this TEM image, and seeing this TEM image and EDS, and this is the AFM, and from this micrograph, I can confirm that there is the nanoparticle, and from this AFM spectra, this is the height image of the AFM spectra. According to this height image spectra, we can say that there is the surface of the nanoparticles is overall in same size, And after this, I have focused the numerical study, because nowadays nanomaterial, if you synthesize nanomaterials and you want to go into publish in the good journal, that time you have to focus on the theoretical studies. Otherwise, they want this theoretical study behind it. So I designed this. This is the one flavonoid molecule. It is already in the mango flower extract. That is, it is known as 3-hydroxyflavone. And 3-hydroxyflavone, it is the silver, and I already interacted with this silver, and these are the structure of the LUMO and HOMO. here is the best good point is that according to this Gaussian report, I compare the IR spectra with theoretical and the practical, that it's almost similar. So it is the good point for correlation between this practical and the theoretical. And next point, I would like to focus the nanocomposite material. Before going to the discussion of the nanocomposite using these nanomaterials, I would like to focus on the graphite and graphene, some basic points of the graphite and some basic point of the graphene. Graphite is a mineral, and you can get this from natural, and it's a multi-layer structure, but graphene is a one atom layer structure, and it's graphene is more better than the graphite. So scientists are focused to design the graphene from the graphite, and so many reports are already in journal that you can find. And I want to focus. I have synthesized this material, that is silver nanoparticles with reduced graphene oxide, RGO, and nanocomposite material. Graphite, this is collected from the mineral, that is ore, and it is already grinding and the graphite flakes. Using the Humer's method, modified Humer's method, you can synthesize the graphene oxide. After the synthesis of graphene oxide, you can you will just disperse it in water and adding some reducing agent, and you will get this reduced graphene oxide. After this step, I just mix the silver nanoparticles in here, and I will get this silver nanoparticles with the RGO nanocomposite. What is the difference between graphene oxide and the reduced graphene oxide? Graphene oxide mainly contains different functional groups that reduces its conductivity compared to RGO. On the other hand, in the RGO, percentage of oxygen containing functional groups reduced, and percentage of reduced, and the percentage of the sp2 carbon atoms increases, which increases its conductivity. There are several techniques for reductions of the graphene oxide and reduced graphene oxide. But I follow in here the biological reductions, and I have used this sodium borohydride as a reducing agent, and this is the probable mechanism of the reductions. And then characterization technique is there, and I have used this characterization for these RGO and the silver nanoparticles nanocomposites, and you will see here that there is a very homogeneous dispersion of the nanoparticles on the surface of the graphene oxide, RGO, reduced graphene oxide. And it is the TEM image, and it is the ACED, and there is a particle already, silver particle, and this is the height image of the AFM. And this is the one most efficient technique for characterization of the nanoparticles, that is X-ray photoelectron spectroscopy, that is XPS. And according to this XPS, already I have mentioned that graphene oxides have the higher number of oxygen, but in reduced graphene oxide, it will be lower number of oxygens, means low intensity of oxygen value. And it will be more if you see the percentage of carbon, that time you will see here, and it will be higher, and it is more higher. That is, it is the reduced graphene oxide with the with this graphene oxide with these nanoparticles. And these are the deconvoluted image structure, and you can get the idea about the binding energy changes, and from these changes you can predict this, this is the binding energy difference. And now I am going to discuss the nanostructure for wastewater purification, and why we should focus on the wastewater purification? Because nowadays, from the industries, there are so many effluent is coming to the sea water or river water. They are containing of the toxic heavy metal ions, toxic dye, chemical organic dyes, and so many things is there. So it is very harmful or dangerous to the aquatic life. You seen there is some pollutant in the of the surface of the water, and there is some color substance of the surface of the water. So we need to clean this water. Then question will come how to clean, and this is very toxic of this human body also. And this is mercury. If we get more mercury consumption, that time we will suffer stomatitis, and if it is cadmium, that is pneumonitis and anemia, chromium 6, and so many things, so many effects is there. Particular, I would not like to focus detail. So thus, removal of the solid particle, toxic dyes, and heavy metal from wastewater necessary to protect environment and reuse of water. So how to clean water? There are so many processes already reported there that we can use the chemical precipitation, solvent extraction, membrane filtration, RO, that is reverse osmosis. We are already use this reverse osmosis technique to purify our drinking water in household. And this is the electrodeposition, population, and absorption. These are two techniques for uses to clean the water from the wastewater of the industries. And now I would like to focus on the catalytic hydrogenation. This is the technique of the using the nanostructures for wastewater treatment. I have used this methyl orange and used the 4-nitrophenol, paranitrophenol. And you are getting this. Suppose there is very light intense of the paranitrophenol in water, and you will add this nanomaterial composite, and you will get this clean water. And I have already studied the kinetic study of this reduction technique, and I get this result almost in pure water within the 11 minutes. And as per the methyl orange also, it's become colorless within the 12 minutes. And it is the mechanism. There is the nanomaterial and that is the metal hydride bed, and from this metal hydride bed, the surface, and these molecules are getting to the touch of the surface, and hydride becomes these reactions and reduces the materials, toxic materials. And then if you have any interest to see in more details about this type of research, and then you can find my other publication regarding green synthesis of nanoparticles. It is in Journal of Analytical Science and Technology. And this is in, I have used some novel biodegradable graft copolymer, sodium amylate, grafted polyethylene dimethyl acrylamide, coacrylic acid. And it is with the European Polymer Journal, and the green synthesis, you can see it. At the time of 2009, when I was in a PhD student, that time I see this I saw this publication in the, and I have read it. The Kaluria et al. They are published this report using the glutathione and dithioethylene and 16 modified gold nanoparticle in presence of polyethylene glycol. It is very good material for the detection of the arsenic in water. At that time, I was thinking that if we can design such type of material that will be helpful for the layman, at the time of taking drinking water, they can easily test this material, this water, that there is any arsenic or not. So I am thinking, it was my mind. I always try to get some result from this. But unfortunately, I am doing that type of research before I have discussed. That time I got some results from this mango flower extract, which are showing positive response towards arsenic also. It is you see the color of the mango flower extract in here, and after the arsenic, there is some color changes. So I have completed this research work.
Excuse me, sir.
Okay.
I don't have much time actually. Sorry for that, but you have to finish it within next.
Okay, I or two or three slides only.
Yeah.
Okay, thank you. And I have done this experiment, and I get this result, and it is already published in the Applied Surface Science. And I, using the ICP OES, I am getting this result. There is this, I have used this solution, its details, and it is the mango flower extract. Using this mango flower extract, I have evaluated the main component of this using this LCMSMS, that is liquid chromatography mass spectroscopy by mass spectroscopy, and I am getting this result. 4 ppb is the FLV 3-hydroxyflavone and this mangifera indica. And this is the theoretical study according to this experimental study also, and this is the already I have discussed, and these are the characterization. And after all, I want to skip this, and it is useful for the groundwater sample also, and I skip it. And according to this final report, it is helpful for this wastewater arsenic detection to 200 to 2000 ppb at optimum conditions. These are the theoretical study also. If you would like to, then you can go. And the future scope, we can design this material and you can use this for energy storage application, water remediation, catalytic application, and biomedical application. And I would like to thank you. I am grateful to Dr. Dept Tripathi, Dr. Tapus Koila, for Professor Jun Healy and Professor Chunun Kang for their good wishes. I am also grateful to Dr. Tapanandu Kamila and the principal of Narajole Raj College for giving me this platform. And for this list, you can go to my Google Scholar. And I, as a guest editor of this special issue, Sustainable Wastewater Purification by Technology, I invite you all to read the paper, Sustainability, and publish this material. Now, I am going to thank you to all. And please be careful about coronavirus pandemic. Thank you. Thank you for your patience.
Let's all thank Dr. Koila for his wonderful presentation. Unfortunately, again, we really don't have time for the question and answer session. So again, I request all the audience to please contact Dr. Koila personally through his email ID if you have any doubts. So with this, we are all done with our invited lectures. Now it's time to quickly go into the paper presentation session. We have 10 such paper presenters to be to present their work. So, but before that, I have some 3 quick announcements to all the paper presenters, because we are running short of time, unfortunately, but we have to finish it in time. So I would request you to finish your presentations much below 10 minutes. Really, we don't have 10 minutes. It's preferable if you finish it in 8 minutes, preferably. That's number 1. Number 2 is that all your full-length paper that needs to be submitted within the date which has been given in the brochure, and they will be published after a formal review is after the formal review is over. And we have already shared the book of abstract in the WhatsApp group in which you have been registered. So with this, we will start with the paper presentation. Our first presentations will be done, will be given by Mr. Bappa Sonakar from Panchkura Banamali College, and he will be talking about temperature dependence impedance spectroscopy of some interesting ceramic materials. So Mr. Kaur, you can start.
Okay. Can you listen me?
Yes, absolutely.
Good morning to everyone. Actually, let's start my presentation. The entitled is Temperature Dependence Impedance Spectroscopy of SrCO3 modified BaTiO3 Fe2O4 multiferric ceramic materials. Before start, these contents are this following. Actually, first, what about multiferric materials and the type of multiferric, applications with example, present research work, sample preparation, different characterization techniques, and next one, the result and discussion. In this result and discussion, 4 items were shown in the next slide. The following, that is structural analysis, scanning electron microscope analysis, and the complex impedance spectroscopy, and the Nyquist plot of this material. the first I want to see the basically the complex impedance spectroscopy, but in this particular work, and I showed the good multivariate property which I have said just earlier in my end title, and this property like a good magnetization and good polarization is present, and this is also a high dielectric constant and which has a low dielectric loss or tangent loss. And then I just want to say what is multivariate. Actually, basically, multivariate material is simultaneously two type of properties is present. That is ferroelectric or ferroelastics, and ferroelectric ferromagnetic, either ferroelastic or ferromagnetic. Which in this type of material which is present, this type of material is called the multivariate materials. Basically, there are two type of multivariate materials, type 1 multivariate materials and type 2 multivariate materials. The common material type 1 multivariate materials where the high transition temperature and there is a low dielectric constant, large electric polarization, but the weak magnetizations or remnant magnetization. Basic example of the BiFeO3 is the type 1 multivariate materials, and type 2 multivariate material actually which is belongs to the lead based material. There where the low transition temperature, the low dielectric loss or tangent loss, but there is a strong coupling between the electricity and magnetism. The interesting thing is that in this my present work, I want to say only the impedance spectroscopy, but in this work I showed there is a not to present here which has the transition temperature is nearly room temperature and good remnant magnetization and polarizations. So this is also important thing that this is not the lead based material. So this my material is belongs to the type 2 multivariate materials, and here huge type of applications are present. This material have some various in type of application like data storage, spin ball, spintonic, quantum electromagnetic, microelectronics, and also it has in application in software electronic device and also memory device. In this memory device like non volatile FERAM, capacitors, piezoelectric transducer, etc. Basically, my present work is SR dope BATI3 ZnFe2O4 in the solid state reaction, high temperature solid state reaction technique. And we have to study this material, their structural impedance and spectroscopy properties. And the composition is there is 7:3. That is BATI3 says 70% and ZnFe2O4 is the 3%. This is the simple material preparation. We take the raw materials in the proper weight by ingredients, then it mix in the aged motor, and this after mixing this mix in aged motor with ethanol for 2 hours, and this ready for the XRD. And after this mixing, calculation is at 1000 degrees centigrade for 5 hours. Then it's comes to milling and the isostatic press in hydraulic press to make the pellets, and these pellets were centering at 1050 degrees centigrade for 4 hours, and these pellets were silver coated in the both surface very finely, and these silver coated pellets are ready for the characterizations. There are the result and discussions. Actually, in this slide, we have to shown that there is sharp the X-ray diffraction, sharp and distinct peaks appears, which is indicating this very good synthesized material, and all the sample display the typical diffraction peak, which is pure perovskite structure, perovskite, and with any impurity type of. And the average crystalline size is calculated is 40 nanometer. Use the Serre formula, which is the k lambda by beta cos theta. Beta is the half wide full maxima. This material. Next slide is the scanning electron microscope, where from that we have seen that this is a very clear picture, and the grains and the grain boundary are appeared very sharp, and for the sintered sample, the microstructure structure is denser throughout the surface, and some very scattered few pores also is observed. And we have calculated the average grain size should become 300 nanometer to 600 nanometer. And the main things is the complex impedance spectroscopy of this material. And this is for the image impedance, and conductance is basically actually important to study the conductive and conductive and resistive properties of this material. Whereas the imaginary part, which actually shown in the right side image, is a imaginary part which is suitable for the relaxation process. And we want to show in the left hand image, actually there all this type of image exhibit the temperature dependence of real part of impedance with frequency. All plot shows a low frequency dispersion, and the initial decrease we have to show there the initial decrease of Z dust value with frequency may be due to the slow dynamic relaxation process in this material, which may be probably due to space charge, and this, and the finally this all the march in the single line, and this this in the higher frequency, and this may be this attribute to the release of space charge. And in the right side, just in the imaginary part of with frequency, this imaginary part of the impedance shows the symmetric nature, which suggests the non-deviate type of behavior of the material. The next slide is the impedance spectroscopy. This figure shows in different temperature from that is low temperature, that is means 150 degrees centigrade to 350 degrees centigrade. And this Nyquist plot shows the real impedance with imaginary impedance. Actually, you have to see that only one semicircular arc is represented in the lower temperature region, which suggests the grain resistance. And when the increase the temperature, the semicircular arc is depressed towards the Z dust axis, that is real impedance axis, which is reduced also the grain resistance. And when more than one semicircular arc, that implies that this material is the grain boundary resistance also is present. So this implies that with increasing temperature, the grain resistance will decrease. This implies that this shows the negative temperature coefficient of resistance, that is NTCR behavior of the semiconductor. And this is the conclusion. These are we have followed the previously. The X-ray diffraction shows that the sharp and distinct peaks, indicating that synthetic material is highly crystalline.
Sorry to interrupt you. Actually, your time is up. You have to just finish it within few seconds. Yeah.
Okay. Okay. Yeah, this is the just one slide. Just one slide.
Yeah. Please finish it. Yeah.
The grain distribution have been found is homogeneous and size is 5 micrometers, and this imaginary impedance shows the NTCR behavior. And also complex impedance spectroscopy is shows that the contribution of grain boundary and grain effect on this material. And this Nyquist plot is also support the NTCR behavior. These are the reference, and thank you.
Okay, so let's thank the speaker, Mr. Bappasunakar, and we'll go to the next presentation by Dr. Kalipada Bankuda from Tamralipta Mahavidyalaya, West Bengal. So over to you, Dr. Kalipada Bankuda. Yeah, please start your presentation. Dr. Bankuda, are you present? Dr. Kalipada Bankuda, are you present? If you are not available, if the speaker is not available, we can go to the next person who is. So we can't see Dr. Kalipada Bankuda right now. So we'll go to the next presentation once. Okay, Kalipada Bankuda is coming. Okay. Sorry. Yeah, you can continue with your presentation. Please carry on. Yeah. Your audio is not clear. Dr. Bakuda, please check your audio, please.
I am audible?
Yeah, you are audible now. Yeah, please share your presentation.
Yes. How will we share? But
Yeah, in the bottom right corner, you can see the present now option. Just click on that, then you can choose one of the options like entire screen. Then go to the
change
share.
layout, change layout, green screen.
No. In the bottom right corner, you have this present now option. Your presentation is on actually. I mean, presentation mode is on, but your slide is not on. Can we just?
Sir, your presentation mode is on. You have to just open your PPT.
Yeah.
My PPT is open, but not sharing.
Then just cancel the presentation. Okay.
Yeah, and do it again.
Do it again, yeah.
My PPT is open, but not find the window.
Can you just please redo this presentation mode again? Like stop sharing now and then go to the presentation mode again.
Stop presenting.
Yeah. Then
now start it again. Sir.
Yeah.
Present now.
Yeah. Then select.
Yeah.
Your window and then open your presentation in front of you.
Is it viewing the presentation?
No.
Not at all.
No, you are not in presentation mode actually.
After you press the present option, you have to select either of those two, the first two. Your entire screen. Yeah. Now you have to open your present. Yeah. Now we can see your slides. Yes.
Are you visible me?
Yeah, your slide is visible. Go to the first slide, please.
Okay.
Yeah.
Are you visible?
Yeah, it's clear.
Myself, Kalipada Bakuda from Tamil Nadu Mahavidyalaya. I discuss the topic silver nanoparticles with synthetic approaches and applications. In previous lecture presenter, Dr. Kole, my friend also discussed the topics in details, but I discuss it in a review work mainly. In introduction, nanoparticle are tiny materials having size range from 1 to 100 nanometer. Its synthetic approaches and applications are interesting scientific field. Broadly speaking, there are two approaches of nanoparticle production. One is top-down, that is bottom-up chemical method. In top-down method, we generate small particle, that is nanoparticle, by milling from bulk materials. But chemical method, we produces nanoparticles by starting from the atomic level. There is growing attention to produce nanoparticles using environmental friendly methods, that is green approach. In synthetic approaches including polysaccharide, biological and irradiation method, which have advantages over conventional method involving chemical agents associated with environmental toxicity. Chemical agents are environmental toxicity. Various physical, chemical and biological methods have been developed to obtain silver nanoparticles of various shapes. Physical methods are evaporation, condensation, laser evolution, and so on. Chemical approaches are reduction by trisodium citrate, reduction by sodium borohydrate, UV irradiation, gamma irradiation, laser irradiation, microwave electrochemical method, polysaccharide method, tolerance method. In this section, I discuss polysaccharide method. And also biological approaches are synthesis of AgN silver nanoparticles by bacteria, by fungus, by plants, etc. Chemical approaches are the most common approaches for synthesis of silver nanoparticles. In general, different reducing agents are used. They are sodium citrate, ascorbate, sodium borohydrate, elemental hydrogen. Reducing agent reduces silver ion to silver metal, which is zero, class is zero, followed by agglomeration into clusters. These clusters eventually lead to formation of metallic colored silver particles. It is important to use protecting agent, that is capping agent, and or stabilizing agent to stabilize dispersed nanoparticles during the course of metal nanoparticle separation and protect the nanoparticles, avoiding their agglomeration. Agents of surfactant functionalities, that is thiol, amines, acids, and alcohols for interaction with particle surface can stabilize particle growth and protect particles from agglomeration. Stabilization of nanoparticles include surfactant and polymers with different functional groups such as carboxylic acid and different type of polymers, that is polyvinyl alcohol, polyvinyl pyrrolidine was also reported as stabilizing agent. Polysaccharide methods are in polysaccharide method, silver nanoparticles can be prepared using water as an environmental friendly solvent, and polysaccharide has used as reducing as well as capping agents. Synthetic starch silver nanoparticles can be carried out with starch as capping agent and as reducing agent. Also, silver nanoparticles can be synthesized by mixing two solutions of silver nitrate and starch and NOH solution as a reducing agent. Images of different colors of silver nanoparticles. Biological approaches, the bioreduction of metal ions by combination biomolecules found in the extract of certain organisms, that is enzyme, proteins, amino acid, polysaccharides, and vitamins, that is environmental benign. So silver nanoparticles by bacteria. There are several reports where silver nanoparticles are synthesized using E. coli, Bacillus subtilis, and etc. etc. Synthesis of silver nanoparticle by using fungus. Fusarium, Oxyporum, Phenocryptosporium, etc. Fungus are used to synthesize the silver nanoparticles. Synthesis of silver nanoparticles by plants. This is the vital things because we want to synthesize silver nanoparticle using green approach because environmental, in the point of environmental view, we use silver nanoparticles by plants. Green synthesis of eco-friendly, low cost can be used for large scale synthesis. No need to use high pressure, energy, temperature, and toxic chemicals. Not require any special culture preparation and isolation technique. These are the advantages of the silver nanoparticle synthesis by using plants. Reported plants, that green tea plant extract, black tea extract, alfalfa, geranium, etc. Leaf extract are used to synthesize silver nanoparticles. Green tea extract can be used as a reducing and stabilizing agent for the biosynthesis of silver nanoparticles in aqueous medium in ambient condition. Plants are able to reduce silver ions faster than fungi or bacteria. In biological synthetic routes, it is shown that the Ag nanoparticle produced by plant are more stable compared to the other chemical or organism methods. Application of silver nanoparticles, the use of silver in wound management can be traced back in the 18th century, during which silver nitrate was used in the treatment of ulcers. The antimicrobial activity of silver ions was first identified in the 19th century. However, after the introduction of penicillin in 1940, antibiotics became the standard treatment for bacterial infection and the use of silver diminished. Silver began to use again for the management of burn patients in the 1960s. More recently, silver nanoparticles are great interest due to their extreme size, small size, and large surface to volume ratio that in their properties compared to their bulk compartment. Medical applications, bone cement, toothpaste, surgical wounds, face mask, wound dressing, and burn treatments, disinfecting medical devices. Other applications, catalytic activity, sensor, packaging, textile coating, cosmetics, water treatment, detergents, soaps and shampoos, hair and water filters, and so many. Toxicity of silver nanoparticles. Argyria is the most frequent adverse outcome from exposure of silver nanoparticles. For instance, prolonged ingestion of colloid silver can change the color of skin and cause blue-gray appearance of face. Some authors have claimed that Ag nanoparticles possess low or zero toxicity to human cells, but however, other studies show that silver nanoparticles are toxic to mammalian cells derived from skin, liver, lungs, and brain. Generally, the toxicity of silver nanoparticles depends on their size, shape, and chemical composition and surface modification. However, uncoated silver nanoparticles are more toxic than the coated silver nanoparticles. Notes: the most commonly used concentration of commercial silver nanoparticles is 20 ppm. Aldis offers several silver nanoparticles suspended in a dilute aqueous citrate buffer, which is weakly associated with the nanoparticle surface. The citrate base agents was selected because weakly bound capping agents provides long-term stability and is readily replaced by various other molecules, including thiols, amines, polymers, and proteins. Silver nanoparticles may be stored 4 degrees centigrade in the dark because they are photosensitive. Silver nanoparticles undergo fast oxidation and easily aggregate in solution.
Dr. Bankura, sorry to interrupt you. You have 1 more minute. Yeah, please finish there.
Yes. Conclusion.
Conclusion.
In this lecture, I discuss the synthesis of silver nanoparticles by using physical method, biological method, and application of silver nanoparticles, and also the toxicity of the silver nanoparticles. Thank you.
So let's thank the speaker, Dr. Kalipada Bankura. And we don't have the introduction session for the timing. So we will go to the next presenter, who is Dr. Sweety Jain from Samrat Ashok Technology Institute, Madhya Pradesh. Over to you, ma'am. Yeah, please share your presentation.
Yes, sir.
Yeah, please go to the present now.
Yes, sir. Yes, sir.
Yeah.
See, visible, sir?
Yeah. Please go to the full screen mode. Yeah.
Yes, sir. Yes. Good morning to all. This is Dr. Sweety Jain, as Assistant Professor in Electronics and Communication from Samrat Ashok Technological Institute, Vidsa. I am presenting here my paper, Determination of Soil Suitability based on different techniques. Micro-strip moisture sensors play a very important role to protect the soil from the moisture content. And in agriculture field, soil moisture measurement is needed to find out finest period to plant and cultivate the field. Various research papers were studied, so there were very different techniques like RF reflectometer, time domain reflectometer, with their limitations like a complex, large measurement setup, time consuming. So keep in mind that these research gap, I adopt the microstrip sensor. Why I am adopting this microstrip sensor? It is a very cheaper, versatile, accurate, easy to fabricate and portable. And a very important part says microstrip sensor, you can see in this figure, this is a ground plane dielectric substrate and the patch. Now, mathematical aspects of a use for a sensor. For a rectangular patch, we use this formula, and for a circular patch, we use this formula for a design of sensor. Now, if we talk about the methodology, so firstly, we have to design the microstrip sensor on CST software, then fabricate it on FR4 substrate. Then actual moisture content is obtained with the help of microwave oven drying technique. And PMC can be determined with the help of vector network analyzer, and it can be measured the reflection coefficient. Then finally determine the MRE. Now, AMC calculation, you can see in this figure, in this slide, oven drying technique is used to determine the actual moisture content, and this formula is used with for determining the actual moisture content. So you can see here M weight minus M dry upon M weight. So this is a mass of sample before drying, and M dry is the mass of sample after drying in oven. Now, if we talk about the PMC calculator predictive moisture content, so here firstly we have to take the different samples operated at a different water quantity and measure the reflection coefficient with the help of vector network analyzer. Then after that, graph is plotted between the actual moisture content and the reflection coefficient. Then again we will take the different sample with a different water quantity and the graph is plotted between the major reflection coefficient and the frequency. Then finally got the PMC, and the calibration equation will be obtained. So you can see the MRE can be determined with the help of this formula. MC actual is determined with the help of oven drying technique, and MC predicted with the help of this VN. Now I took this reference paper. You can see in this figure, this is a rectangular shape of sensor. Its size is 40.5 by 48.4, and it is a simulative on a HFSS software. Then after that, this is a return loss, so achieve the 10 dB. Here is a 20.28.06, as well as in this third figure you can see here it's a VSWR, so it's a 1.17. So I achieved this good return loss and the VSWR. So we can say that microstrip sensor will be worked proper. This is only analysis term. If we talk about the experimental, so you can see in this figure, when the dielectric constant is increasing, then the moisture content of the soil is also increasing. I am also doing my study on this paper, and due to the lockdown, I was unable to go outside for measurement results. So my study is going on. I hope I will be complete my study in future. So conclusion is that the main microstrip sensor is very important to detecting the moisture content in soil, not only in the soil but also in the agriculture fields like rice grains or the other thing. So we can use it. And now reflection, we can also study this. When the reflection coefficient is increasing, then the moisture is also increasing due to the decrement in the dielectric constant and the loss of the water molecules. So I referred these papers and in the study, and my achievements is I have published many papers in SCI and other journals. I have attended international national conference. My PhD thesis also selected in Baba Atomic Research Center and presented in IIT Jodhpur. I attended various workshops, short-term course, faculty development program, and I reviewed research papers in SCI journal. I'm a editorial board member in the International Journal or the Journal Paper, and I'm graduating in Pavlan's Academy Practical Peer Review course. Thank you.
Let's all thank Dr. Sweety Jain for such an informative session.
Yes. Thank you, sir.
Our next, welcome, ma'am. So now we'll have our next talk, and our next talk will be given by Dr. Amit Kumar Bhuiya from Department of Physics, Government General Degree College, Gopipallapur 2, and he'll be talking about metal nanoparticles, protein interface, corona formation, and interaction analysis. Sir, over to you. Sir, you have to unmute yourself. You are still, your microphone is still in mute. I can see that. Sir, you're in a screen. Your microphone is off. Bottom left. Sir, your microphone is off. Go to the Google Meet. Please open the Google Meet. We can see your screen. Go to the Google Meet. Yes. Open that. Yeah. Now look at the bottom. Now you can see that there is a red circle. Red. That.
Okay.
Yeah. Thank you.
Yeah.
Now go to the presentation and.
It is visible?
Yeah, sir. Visible. Please start.
Okay. Thank you, and good morning to everyone. My present talk is the subject metal nanoparticle protein interface, particularly the corona formation and the interaction analysis. I myself, Dr. Amit Kumar Bhuiya from Government College, Gopipallapur 2. My collaborators are Dr. Tabarnu Kamil, Narajole College, and Professor Purit Shah, Videshwar University, and Dr. Piyushkanti Samanta, Contact PK College, and Professor Devasis Raj. What do you mean by nanomaterials? First, I discuss about nanomaterials. Actually, nanomaterials having the size between 1 to 100 nanometer with new properties compared to the bulk material, then it is called nanomaterials. Example of nanomaterials is the size of hydrogen atom is 0.04 nanometer, protein size 1 to 20 nanometer, and future computer size 180 nanometer. Diameter of human hair is large, it is 10 micrometer. At the nanoscale, there are many properties like optical, physical, chemical, and biological properties are changes compared to its bulk material. This is one of the important properties, that is the surface by volume ratio. In nanoscale, surface by volume ratio is large compared to its bulk counterpart. This is an example of a cube. When a cube cut each faces by half of its original length, then the surface area gradually increase almost 2 times of the original surface. Then I enter the interest of the topics, why nanoparticles are interact with biomolecules or protein. For example, like silver nanomaterial, which surface area gradually increases with changing the size, and also the surface energy changes. Here is the example of silver nanomaterial. When we change the size from 16 nanometer to 5 nanometer, then its surface energy almost 2 times increases. Means due to large surface energy, it can easily interact with the biomolecules. Also, not only in metal nanometer, but also in semiconductor counterparts, there is a significant change in surface energy which leads to interact with the biomolecules. Then proteins. Proteins is a very fantastic example of nanomaterial. One is the bovine cinnamon albumin, whose dimension is 8 and 8 nanometer. It has a spinal structure and it's important biomolecules or important proteins like biomolecules. Another example is the hemoglobin. Hemoglobin is also a very important biomolecule for the human body. It is a globular protein consisting of 4 polypeptide chain, 2 alpha and 2 helix chains. Next, we enter inside the silver nanomaterials. Why silver nanomaterials are important? Actually, they are important for their unique physical chemical properties. They are also important for different biological applications like antiviral, anti-fragmentation, and also they are used for different in vivo and in vitro applications. Then why nanoparticles, how they are interacting with the biomolecules? When the nanomaterials are come in contact with the protein molecules, then there is a formation of layers. And layers are generally 2 types. One is for corona formation like single soft corona, another is for hard corona. We are interested in the corona formation mechanism also. In the initial stage, there is a most abundant proteins are absorbed on the surface, but in the time, with respect to time, the affinity of the proteins is higher in the nanoparticle protein corona forms. The structure and composition of corona depends on the different properties, size, shape, and functional properties. This is the real scenario even inside the human body. When they come in contact, just the corona formation occurs because nanomaterials are used for drug delivery treatment and different in vivo applications, and in this way they are formed corona inside the in vitro or in vivo system. But what will happen when the corona is formed? This is our study or interest. Now we are entering inside the silver nanomaterials. We grow different silver materials having 5 to 10 nanometer with different colors, and we also observe different surface plasma resonance properties like from UV spectroscopy. This is another kind of report by other researchers, and we also characterized by HRT analysis and observe their size and also their crystal length, crystalline properties. This is another silver nanomaterials where you clearly observe that they are well crystalline nature, having different faces, face HCC-like structure, and they will enter inside the interaction study. When they are contact with biomolecules, then their surface plasma resonance changes significantly, and also the tryptophan band of the protein molecules are changes significantly. and there is a change in wavelength with respect to different concentration of silver molecules is observed. And also the change of surface plasmon is fitted by the following equation, and we observe different lifetime of the corona formation and also the binding mechanisms. And we also studied the interaction property by HRTN analysis, and we also observed that the sat pattern of the bioconjugate, which is clearly a amorphous-like nature because of the surface inversion or surface conversion from one phase to another phase. And we started the dynamic light scattering analysis, where we observed that when the corona formation occurs, then the size of the corona changes with respect to time. And the dynamic analysis and corona thickness change in time almost 250 minutes. There is a change in thickness almost 80 nanometers. And also studied the zeta potential and also correlated functions of the nanobioconjugate. We observed the diffusion coefficient and also changing significant change of the zeta potential due to surface change of the surface properties. And also we studied the time-dependent circular dichromosome spectrum, where we observed the change of alpha helix and beta C with respect to time, almost 67 to 64% changes occurs in alpha helix, and also 8 to 8.45% of the beta helix change observed. Then you observe the cell deformation by emissions quenching mechanism under different temperatures, and we studied the different binding properties, binding parameters like the binding constant, also the free energy like delta G, delta H, delta S, entropy changes, etc. And we observe the different kind of binding. One is electrostatic binding, another is hydrogen binding, another is hydrophobic interaction. Is observed from this kind of interaction. Then we studied the visualized aspect of hemolysis phenomenon, and we observed that in case of hemolysis, the protein-coated nanomaterials are highly biocompatible, but in case of bare nanomaterials, they are not biocompatible and they easily destroy the RBC. But in case of surface coating by coating nanomaterials, they are not hemolysis. This is an interesting observation which shows that the biocompatible property of the protein-coated nanomaterials and also the future aspect of the biomedical application of the protein conjugated nanomaterials. I acknowledge to DST Phys Department of this university and also on the Thank you.
Let's thank Dr. Bhuya for such an informative presentation. Thank you, sir. Our next talk will be presented by a person whom I know from my MSc days, and it will be presented by Dr. Devashish Otto, who is currently working in Government General Degree College, Kharagpur 2, and he will be talking about an interesting theoretical model called thermal spike model. So, Devashish, over to you. Devashish, you have to unmute yourself.
Hello.
Devashish, are you there? Seems like there is some technical issue. Arif, can you check whether he is there in the room?
He just left the meeting. Some network issue maybe.
He just left the meeting.
Yes, yes.
Yeah, we all can hear you. Devashish, please start your presentation.
From where that present screen?
Yeah. You have to present your screen, and you have to
present your screen.
Yeah, and you
start presenting.
Yeah, start presenting, and then you have to open the presentation.
Just start now.
Yeah.
start now. The presentation in a folder. So how can I go to there?
You have to minimize everything. You just minimize this thing and just minimize.
Oh, okay.
Yeah, minimize this thing in your phone. This one.
Okay, okay.
Yeah, yeah.
Okay.
Now we go to the presentation. We can see your screen.
Okay. Okay. Thank you. Okay.
Yes, you can make it full screen.
Oh. Oh, this is a PDF file. It is difficult to make the full screen. Okay.
Okay. No problem, Devashish. Carry on.
Okay. And my talk is the role of swift heavy ion irradiation in material science in consequence with thermal spike model. I will give a brief description of that. I would like to thank the organizer of Narajole College for presenting this talk in this seminar. That is basically now. My outline is basically how swift heavy ion induced mixing happens in the ion matter interaction occurs, and between this and the mechanism is mainly underlying this is the thermal spike model, and some applications are there. So basically, I want to tell that how ion matter interact between this, and incident ion comes with energy naught, and it incident on an atom. There is the different two type of collision. One is the nuclear, another is the electronic type. What is called the elastic part, another is the inelastic. We basically know if in the case of medium, that is in the case of the incident the energy is not, then it may excite the atom. In electron excitation occurs, then the excited delta E is the E naught minus E excited basically, which is basically again you can collect that E recoil plus E excitation, which is basically the excitation energy comes from the electronic. So E electronic plus E nuclear, or E inelastic plus E elastic. The nuclear part is the elastic part and the inelastic part. So a material medium, inside a material medium, when a particle, basically ion incident, it travels a path x, and after it traveling a small path dx, it loses energy through the formula dE dx. So dE dx contains the electronic component as well as the nuclear component. So electronic component is the AC value, and nuclear component energy loss is called the SN. Now, swift heavy ion. So there is heavy ion medium, heavy ion metal interaction. There are two type interest are there. One is called the dominant elastic collision, another is the dominant inelastic collision. In the elastic collision, what happens? Basically, there is a material modification or atomic displacement occur, and in the inelastic part, there is excitation occurs. Atomic excitation occurs. In the swift heavy ion interact with atom, then the excitation occur in elastic part. So there is no atomic displacement. That is no material modification as expected. So in our case, now to explain this type of phenomena, the theoretical modeling, what is doing, that is the thermal spike model. In this model, it is called the electron hits a material, then it deposits on an ion hits a material. The target in this material, that basically the energy shared between the electronic to lattice subsystem, and the medium is thermalized. And the time scale, basically the y-axis shows the time scale, different time scale, that how it is thermalized to the medium basically. So this is happening due to electron and phonon. Phonon means lattice electronic subsystem to lattice subsystem, the temperature evolution. There is the phonon in the medium factor. So it is the schematic diagram of thermal spike model is shown here. Now it is mathematical model. What I want to say is the two temperature model. Basically, it is a model. This model describes basically two coupled differential equation, which is that interact with basically how swift heavy ion interacts with a matter. Then it goes like a cylindrical geometry. When it comes to in a material, incident on a material, then it, according to its energy, it penetrates. Then a molten zone and ion track is forming. So then in that ion rack, you will consider the cylindrical geometry. The first equation is for electronic subsystem, second equation is for lattice subsystem. For two subsystem, there is the value, the parameters T, TA, C, these are all temperature and specific heat for two systems. These are defined here and there. This graph is showing that this for low time scale, how the electronic temperature and lattice temperature evolution, temperature evolution is showing with respect to for the case of nickel. It is a sample calculation with nickel. So this is showing. Now this is the thermostat model, the physics underlying it. Now the experimental point of view, swift heavy ion material modification occurs. We can choose a target material, so our incident beam is required. So swift heavy ion beam. So target material is maybe we can choose the properties due to structural, electrical, and thermal. Different type of properties can affect the target material. It also depends on the mass of projectile. Also the different parameters that ion incident, that fluence means ion current, ion energy. So there are different facilities where the experimental setups are there. That is ion beam irradiation techniques will be applied there. Basically, I have given some example here. 15 megavolt Pelletron accelerator at IUSC New Delhi, 14 megavolt Pelletron accelerator at TIFR Mumbai, 4 MeV cyclotron at VCC Kolkata. And there are different university also have some accelerators, or universities like GGVU, that is 3 MB Pelletron and 2 kV Pelletron in Kurukshetra University, Haryana. Now, in these facilities, what basically is going to happen? One is to the swift heavy ion means ion energy in the range of mega electron volt. That is a higher range. So, according to depending upon energy, the value electronic energy loss in a medium, there are different electronic in the range of values that there are electronic energy loss. So according to it is showing that as per electronic energy loss per kV per nanometer, then different modifications occurs inside the material. One, if it is low, then this type, then this is high AC value, then different type of modifications occur. So one important phenomena is happening between that there are two material. If a ion irradiate in between them, the interface, there will be mixing. It is same between metal insulator, metal semiconductor, metal. Different type of mixing are there, and this mixing also the important roles plays in different applications are there. And another application also in this context, it is important that nanostructure, that people are talking different by synthesis, another method, but in the ion beam irradiation also influence the nanostructure in phase separation, like germanium oxide film formation with nanoparticles. Indium oxide leads to the formation of nanoparticles. So there is a phase separation of a binary MNBI is two binary are there. Then in the by application of swift heavy ion irradiation, we can separate the nanoparticles of these two phase. And the nanoparticle shape, size, and interparticle separation depends on the irradiated beam, energy, and different parameters. So swift heavy ion irradiation also increases the antioxidant activity and biocompatibility. Nowadays, biomedical applications also are there, and also it is induces different FCC to HCD phase transformation are shown there in different phenomena. It is happening, and swift heavy ion has a larger scale of application in our research. And thank you. Hello.
Let's all thank Dr. Devashish Ottwa for such wonderful presentation. Thank you, Devashish.
Okay, thank you.
So our next talk will be given by Dr. Soumya Sundar Moti, Government General Degree College, Keshiari, and he will be talking about silver nano cluster assisted metal ion sensing. Dr. Moti, over to you. Devashish, you have to stop your presentation. Stop presentation. Dr. Moti, are you there? Yeah.
Yes, yes, I'm here.
Yeah, you can start your presentation, sir.
Am I visible and audible?
Yeah, you are audible and your presentation, yeah, we can see your screen. You can make it full screen, sir. Yes.
Okay. Good morning to all. First, thank you to the organization committee of Narajole College giving me the opportunity to present here. My talk is silver nanocluster assisted metal ion sensing. And first of all, what is nanocluster? Metal nanocluster consists of several to 10 metal ions having size around 2 nanometer, and it is a missing link between atomic and nanoparticle behavior. For its discrete bodies tiny size and quantum confinement effect, it shows discrete energy levels and molecular-like electronic transitions like fluorescence. Now, aim of our study is mainly three-dimensional. First of all, facile preparation of fluorescent silver nanocluster. Secondly, application these fluorescent nanocluster into sensor. And number third, the mechanistic study of this sensing behavior. So first of all, the synthesis of this silver nanocluster stabilized by polyethylene imine, that is PEI. So first of all, we have to dissolve the polyethylene imine, that is PEI, into Hepis buffer, aqueous Hepis buffer medium at pH 7. And followed by, we have to add silver nitrate and reducing agent formaldehyde, and it would be stirred in 48 hours in room temperature condition, and after that a pale yellow color solution of silver nanocluster stabilized by polyethylene amine is generated. Now this silver pale yellow color of silver nanocluster has been characterized first with DLS study, that is dynamic light scattering study. From dynamic light scattering study, we can see that the size of this silver nanocluster, the hydrodynamic diameter is 3 nanometer, and the exact size from STEM analysis, it is around 2 nanometer. So this is my first evidence of formation of silver nanocluster of teeny size having 2 nanometer size, and it is not the nanoparticle. Now, in the next evidence is the spectroscopic evidence. The spectroscopic evidence, this silver nanocluster shows beautiful fluorescence emission having high intensity at 435 nanometer in visible region and absorption in 360 nanometer. This 435 strong emission intensity suggests this is the silver nanocluster. Now, the further XPA study suggests that the oxidation state of the silver nanocluster, as from literature survey, we know that the binding energy in 368 and 374 suggests the zero valence state of the silver, and in our results also we can see that the Ag3d 5/2 and Ag3d 3/2 having binding energy 368 electron volt and 374 suggests the zero oxidation state of the silver nanocluster. Now, the fluorescence behavior of silver nanocluster in presence of different metal cations. In presence of different metal cation, we can see that except cobalt ion, the other metal, in presence of other metal cations, the silver nanocluster emission behavior does not change at all. And in presence of cobalt cation in 0 micromolar to 13 micromolar, the emission intensity of silver nanocluster consistently decreases and reaches to a minimum. And from this we can see that this is the bar diagram is the reverse fluorescence intensity plot, and from bar diagram we can see that only cobalt has the characteristic change in presence of silver nanocluster solution, where the rest of the other metal cation does not affect at all. And in presence of cobalt emission behavior, presence of silver nanocluster emission behavior in presence of cobalt does not alter at all in presence of other metal cation. And the LOD limit of detection of this cobalt ion In silver nanocluster fluorescence sensor, it is 2.49 into 10 to the power minus 7. Now, the most interesting phenomena is that upon addition of the cobalt ion, subsequently the size of the silver nanocluster became increased to 10 nanometer from around 2 nanometer. It can be observed from DLS as well as TEM study. The after cobalt 2 plus addition, the silver nanocluster size increases 10 nanometer. And this 10 nanometer size is due to the aggregation of the tiny silver nanocluster and form a non-fluorescence nanoparticle of 10 nanometer size. Now the mechanism of this study. We have to apply the lifetime and pH measurement. Lifetime measurement of silver nanocluster shows that having consistent addition of the cobalt 2 plus ion does not change the lifetime of silver nanocluster in 1.35 nanosecond. And this inferred that the energy level of silver nanocluster does not interact with cobalt 2 plus ion. And in case of pH study, upon consequence addition of the H plus ion in the pH range from 3 to pH range 7, that is higher acidic region, the fluorescence intensity of silver nanocluster decreases as observed in case of cobalt 2 plus addition. This is due to the presence of H plus ion. The imine moiety of polyethylene imine polymer became protonated and it destabilized the nanocluster, and due to the destabilization nanocluster become aggregated to form the nanoparticle and it loses its fluorescence intensity. And the similar observation is observed in case of cobalt 2 plus cation also. If we added cobalt 2 plus cation in polyethylene imine stabilized silver nanocluster, then imine moiety became form complex with cobalt 2 plus ion, and this the strong complex formation, the imine moiety destabilize the silver nanocluster and become this destabilization silver nanocluster become aggregated to form nanoparticle and it loses its fluorescence intensity. Now my conclusion is that the cobalt ion based detection is the strong affinity of PY to cobalt 2 plus with less to destabilization to form tiny fluorescence nanocluster. Now this AJNC also shows its selectivity to biothiol in presence of different amino acids. This sensing behavior successfully applied in vitro cell study and in molecular logic with in further different studies. So thank you.
Thanks a lot, Dr. Somosundar Moti, for his wonderful presentation. Thank you, sir.
Thank you. Thank you.
So we'll carry on. Our next presentation will be delivered by Dr. Kaushik Chandra, who is currently an assistant professor in Midnapur College, and he will be talking about imparting natural compounds and nanomaterials based potential inhibitors of advanced glycosidation. Sir, over to you.
Am I audible?
Yes, sir, you are audible. You can start your presentation.
Also, my presentation is visible to all?
Yes, sir, absolutely.
Oh, thank you very much for the nice introduction. Before I go into my topic, first I would like to thank the Narajole Raj College, who has performing a very good webinar series day by day, and successfully they are conducting the webinar series. I'm really thankful to them, and also I give the special thank to Dr. Tokunundu Kamilka, who insisted me to give a talk, and giving this platform I'm really very happy. And now I'm going to present my talk, which is something there is no relation with the physics, and I am not also expertise in nanochemistry, where the title being stated over here, the recent trends in the nanoparticle and the nanoparticles. I have no connection with the nanoparticles. I have never done anything about the nanoparticles. However, I'm doing my work right now, which has some relation with the nanoparticle. I'm looking for this one. But today I'll give you some overview about some of the aspects where the chemistry and biology are interconnected. And that is why I've chosen my topic, imparting natural compounds and the nanomaterial based potential inhibitor of advanced glycation. So first, before I go into the details about that, I would like to give an overview. What is the glycation, glycosylation, or glycosidation? Basically, when protein and sugar are combined to each other, they form a conjugate, and that conjugate is termed in our in chemical sense or the biological sense the glycation or glycosylation. But there are two pathways for the connection of the protein and the sugar moiety. One is a enzymatic pathway, and another is the non-enzymatic pathway. In our system, when the sugar concentration, when there is protein and the sugar binds in presence of the enzyme in a reversible manner, then the process is called the glycosylation. It is a kind of the post-translational modification of the protein. And because of the post-translational modification, there occurs many good things of the protein, because protein gets folded and protein gets solubilized, which is required for the function to exhibit the function and activity of the protein or specific enzyme. But on the other hand, protein and the sugar moiety can also bind non-enzymatically in presence of the heat mostly in a irreversible manner to form a conjugate, which is typically known as the glycation or glycosidation. But there is a detrimental effect of the glycation because of the combination of the protein and sugar moiety, and it causes the several diseases including diabetic mellitus, cardiovascular disease, renal failure, etc. And this glycation can be considered as a biomarker in our health. There are two ways to get the glycation. When there is a hyperglycemia condition, that the sugar unit is sugar concentration in our body is very high, then there is no scope, or our metabolic system is not good enough to metabolize all the glucose into the pyruvic acid. The process is called the glycolysis Krebs cycle. We all are familiar with this one. But that is not happening due to the high concentration of the glucose. And metabolic system is disturbed. The process in this hyperglycemic condition, or in case of the diabetes, this protein and the sugar moiety in our body system, they are connected via the amino acid lysine and the reducing sugar of the glucose, and they will form the different products. There are many steps, with this, with the combination of this one, that is called the Gibbs base, Amado-B reaction, etc. And there is a possibility to form the many toxic intermediate, and they can connect the protein moiety and therefore form the cross-linking between the protein. This is the one way how you can get the glycation, and that glycation is known as the advanced glycation end product. And there is another way you can achieve the glycation in our body system. In case of the patient, in case of the person with the obesity, there is high risk for the insulin resistance, diabetes, etc. In that case, particularly, the advanced glycation that can harmful to that person. Also, for the normal people, it can be harmful, but that comes from our diet. Okay, especially when we cooked the particular food containing the high protein and the lipid, and that time they are combined, the protein and the sugar compound are combined, and they will form the AG. And that AG, when we consume the food, it comes to our body and it accumulates in our body. So it is the another way to consume the advanced glycation in product from our diet. And this is the way that the food in a food, during the processing of the food, the AG is generated. The broiling, not boiling, it is broiling, that is the high temperature, grilling, frying, roasting. There are many ways you can get the AG in the food, and all are associated with the high temperature. The next thing is that since the major Ag comes from the diet and it accumulates in the diet, and when the accumulation, the rate of accumulation of Ag is greater than the rate of the excretion, then there is a serious health issues, including the pathogenesis of the diabetic complication and other things. And you can see the many diseases are associated with that: the diabetic, cardiovascular disease, renal failure, Alzheimer, aging, all are the serious health issues. Now, in our modern diet, there is always a question which we'll think about: the method of the cooking or the time of the cooking. But time of the cooking is not a big issue for that, because we need to cook. We need to cook until it is processed. But the method of the cooking is more concerning, because during our cooking, especially the Bengali peoples who uses a lot of spices, oils, flavors for their cooking, and therefore what happens is that it is generated a lot of AGs. Sometimes the 100 folds AG is being formed in the food, and that food we contain, and therefore this food are accumulated in our body and it reaches to a harmful situation in the body. And therefore, apparently, we are taking unhealthy food like fish, meat, butter, bread, whatever we are taking. But the way of we are processing this food, that gives us the detrimental effect in our bodies. And there is a chart of this, some of the foods. You can easily see that how much AZ content if you take, say about the 100 gram of the French toast, you can contain that 2,500 of the AG. And the permissible limit is always per day you have to consume such a food that have the below the 15,000 kilo unit per liter of the AG. That will be the good for the health. And the recommendation is that you have to take some boiling, steaming foods, or cooking with some moist water at the low temperature, or you can use the ceramic surface, etc. And this is the science behind that, where this is the typical mechanism where the protein and the sugar unit are connected. I'm not giving the details about that because this is not so much relevant for this one. And now in this slide, this protein, one protein is connected to the another protein with the help of this molecule, which is formed as an intermediate during the process, and therefore the protein system in our body, they are connected to each other and they get precipitated and they get aggregated, and that is the very alarming situation. And now in order to prevent this one, what is our strategy? The simple strategy is to design some of the inhibitor, that means some of the molecule or the drug molecule, which can prevent the formation of the AZ. There is both the natural and the synthetic inhibitor, this one. Now, there are these, here in this slide, we can show the, I am showing here, these all are the typical medicine available in the market. And these are being used to treat the early glycation inhibitor or the late glycation inhibitor. And all you are familiar with this compound like metformin, diclofenac, aspirin, inositols, or you are also familiar with penicillamine, amlodipine. All are very common medicine available in the market, and that is being used for treatment of the glycation. But there are some disadvantage, or you can say the drawbacks of this inhibitor, but still they are being used.
Sorry to interrupt you, sir. Your time is actually up. You have to just wrap it up within 1 minute, please.
Okay, I'm trying to.
Yeah.
And this is the AG breakers. And finally, since this webinar is related to the nanoscience, so it is customary for me to just introduce whether there is any nanomedicine or nanodrug system is available to us which can treat the earlier late stage of the glycation. Yes, we have that. There is no effective drug in that case, but there are some examples of this one where the selenium nanoparticle, which is incubated with the protein and the glucosamine during the incubation, and they found that at different stages they can inhibit the formation of the glycation process, or also they can inhibit the cross-linking between the protein molecule. So this is one of the hope that you can use the nanoparticle in order to prevent this. And various leaf extract also available with the nanoparticle, but these are not so much effective. And finally, I would like to give you some precaution or the warning bell to all of you, because in current pandemic situation, it is important to note that the person with the AG-related diabetic complication are very much prone to the COVID-19 infections. So this topic is related to that one, and I'm also trying to relate with this in my research. So my request all of you, and particularly those patients, be careful and keep maintaining the safe distance. And I'm thankful to my collaborator and my students, Charu and Shuntu, and thankful to the audience for your kind listeners.
আপনি আনমিউট করুন, কিছু শোনা যাচ্ছে না তো?
Sorry, I forgot to unmute. Yeah, so let us thank the speaker, Dr. Kaushik Chandra, for his beautiful talk and the nice presentation as well. So we'll move on to the next presentation, which is by Dr. Gajendranath Maiti from Ashutosh College, West Bengal. So over to you, Dr. Gajendranath Maiti. Dr. Gajendranath Maiti, are you present? Our next speaker, Dr. Gajendranath Maiti, are you present? Can you please unmute yourself and come into the presentation mode? We can't see Dr. Gajendranath Maiti, so we can move. Can we see Dr. Gajendranath Maiti? Is he present?
Arif, actually, I don't think he is present.
Okay, then we'll.
I can't see.
Arif, he has left the chat room. I think you can carry on the next one.
Yeah, okay. So we'll move on to the next presentation, which is by Dr. Ushashri Dept from Jhargram Raj College, West Bengal. So I hope Madam is present. Ushashri Madam, over to you. Please take over the stage.
Can you unmute yourself? Yeah.
Yeah, please unmute it. Yeah, and then come into the presentation mode. Madam, are you having any issue with the presentation mode? Can you see the present now option in the bottom right corner? Madam, can you hear me? Am I audible?
Yes, I can hear you.
Yeah.
Hear you, but cannot connect.
Yeah, so your Google Meet is open, right? So you can just go to the bottom right corner and you have the present now option. So just click on that, and then you go to the like share your entire screen option. Maybe click on that. Can you see it, madam?
Are you seeing the presentation? Are you presentation is visible here?
No, actually I can see it, but no, you have to switch on your presentation mode. Yeah, now it's coming. It's coming. Yeah. Yeah, great. Yeah, your audio and video both are fine. You can continue, madam.
So I am discussing the development of thin film silicon solar cell. I will discuss about solar cell, basic structure of photovoltaic solar cell, working principle of solar cell, amorphous hydrogenated silicon device structure, amorphous hydrogenated and nanocrystalline silicon multi-junction solar cell, efficiency of different types solar cell, and uses of nanoparticles in solar cell and comparison with different types of solar cell, and a conclusion also. There are 3 generations of solar cell. Single crystalline silicon and polycrystalline silicons are in first generation solar cell. Amorphous cadmium telluride and gallium selenide is in the second generation, and dye-sensitized solar cell organic PV or quantum dot PV and perovskites are in the third kind of generation. My main emphasis on thin film silicon solar cell. This is the basic structure of photovoltaic solar cell. Actually, a photovoltaic solar cell consists of light absorber, which convert incident photon into electron and holes, carrier collector that captures the carrier. Generally here, the electrons and holes are the carrier in semiconductor PN junction, and the metal contacts that transfers the carriers into the circuit. The main part of the solar cell is the absorber layer. Actually, crystalline silicon or amorphous hydrogenated silicon is the active layer in solar cell. This is the working principle of solar cell. Actually, solar cell is a specially designed PN junction diode that converts light into electric power. The conversion mainly occurs in 3 stages. In first stage, when PN junction is exposed to light, electrons hole pairs are generated. These are then separated across the opposite electrodes due to built-in field produced in the PN junction, and the separated carriers accumulated across the metal contacts and thus generate a potential difference. And this potential difference drive the optically excited minority carrier throughout the circuit, and the solar cell, when exposed to light, behaves as a battery that can deliver power to a load. And from this solar cell, we extract the parameter that is the current, field factor, efficiency, open circuit voltage, VOC, etc. This is the structure of crystalline silicon and amorphous silicon. The long range order is maintained in case of crystalline silicon, and this is the amorphous silicon. Here, the unsatisfied bond is known as the dangling bond, and this is the defect density of the amorphous silicon solar cell. Actually, solar photovoltaic industry is totally dominated by the crystalline silicon solar cell, which 80% occupies the PV market, and the efficiency is 24%. But it is very bulky and has high material cost, and its wafer thickness is also 300 micrometer, and at high temperature is required for the formation of PN junction. For this fabrication cost of crystalline silicon solar cell, the scientists are looking forward to amorphous silicon solar cell. And this is the amorphous silicon solar cell is produced generally thin film technology, and this is most mature and commercially available material, and its optical absorption coefficient of the order of 10 to the power minus 5 centimeter inverse with the adjustable band gap, and it is very easy for fabrication over a large area, and the deposition technique is very simple, and the multi-junction device ensures the optimum utilization of the solar spectrum, and it also the cost-effective manufacturing technology. Here, the basic structure of PIN structure, actually the amorphous silicon contains the PIN structure, and amorphous silicon solar cell cannot be constructed by merely setting up P-type and an N-type film, as the lifetime of the photo-excited free charge carriers are too short to separate any significant fraction of them. Such a device would not show any photovoltaic activity, hence an intrinsic layer is incorporated between P and N type, And here we see that the textured front surface which assists in minimizing the reflection of the incident light. But there are some limitation of amorphous silicon solar cell. Actually, this amorphous silicon degrades its efficiency due to prolonged light exposure, and its module efficiency is also very low, and it
Hello, madam, please continue. You are not audible, ma'am. Ma'am, can you listen? Hear me? Hello. We are facing some, I think, technical issues. Let's bear with us.
Like she disconnected
Okay.
from Google Meet.
Yes, we might have some internet issues. So maybe we can move to the next speaker. Actually, we can go back to the previous speaker who was not present or who was having some issues. So he can come back and give his presentation. He might be having issues with the video, so he will be actually giving oral presentation without his slides.
But
so
unfortunately, he hasn't yet entered the chat room, Arif. I guess.
Oh, Dr. Gajendranath Maiti is.
Yeah, I can't see his name in the chat room. I can't see that. So I guess we don't have any option other than to continue to the last speaker for today's session.
Okay. Yeah. So we will move on to the last speaker, who is Dr. Taposh Ghosh from same Jhargram Raj College, West Bengal. So let's welcome our speaker, the last speaker of the day, Dr. Taposh Ghosh.
Okay.
Over to you. Yeah,
okay. I will try to present.
Yeah, please continue. Yeah.
Okay. Good morning, everybody. Now I am going to deliver my presentation entitled as Design of Continuous Wave UV Heating in Waveguides in Lithium Niobate. I will discuss little bit about introduction, experimental approach, theoretical approach, finally conclusion. Properties of lithium niobate. Lithium niobate is a versatile material due to its electro-optics, acoustoptics, nonlinear optics properties. It has wide transparency region 0.5 to 5 micron. Its Curie temperature 1144 degrees Celsius and melting point 1257 degrees Celsius. There is a different type of waveguides: titanium indiffusion, photon exchange, femtosecond laser heating, continuous wave UV heating. We are interested in continuous wave UV heating due to its single step process. Without lithography, we can fabricate it. It is after fabrication, the properties of the lithium niobate will remain intact. It was first demonstrated by S. Melis et al. Here, experimental approach basically extraction of refractive index profile from near field intensity profile. There is faces two problems in this extraction of refractive index profile: presence of high frequency spatial noise and mode index or effective index is unknown to us. Extraction of refractive index profile from near field intensity profile. Extraction of refractive index profile play a vital role in device, optical device such as modulator, electro-optic device, switches, etc. So we have to know the refractive index profile from intensity profile. Slowly varying index change of scalar wave equation in written in equation 1, where A is the amplitude square root of intensity. From equation 1 and substrate refractive index NS, we obtain the refractive index change delta NS, delta N, which is written in equation 3. Some result: continuous wave direct UV heating waveguide at 305 nanometer writing wavelength, 35 milliwatt power, 0.1 millimeter per second scanning speed. There the blue color curve indicates the raw data of amplitude profile. If we taking this raw data and extract refractive index profile, we get the red color curve of refractive index profile, which is non-unexpected result. And to get the actual refractive index profile, we have to eliminate the noise present in the amplitude profile. We have to eliminate this noise by third order low pass Butterworth filter. The noise elimination procedure, first Fourier transform of measure amplitude profile in phase domain, and secondly, the amplitude in frequency domain is multiplied by the frequency response of third order low pass Butterworth filter. Finally, to get back the amplitude profile in phase domain, inverse FFT is done. This is the transfer equation, transfer function. The figure A, which is the raw data of amplitude profile, taking this raw data, FFT is done. We get the noise presence in low frequency region. Noise presence in low frequency region. To eliminate this noise, we have to filter by third order low pass Butterworth filter, 200 per millimeter frequency, cutoff frequency. Now from this after filter, we that there is no noise in the filter FFT. To get back the amplitude profile, we inverse FFT is done. We get filter A, but small noise presence in amplitude profile will tremendously increase in its double derivative. So we have to eliminate the noise in its double derivative also. We approach same procedure and obtain the refractive index change profile in figure G. But we observe that the refractive index change is negative, which is unexpected. So we have gradually increased the mode index as from substrate index, and until the minimum refractive index change is 0, and obtain the actual refractive index profile, which is given in figure 8, and mode index in 2.206028. It is the same refractive index profile from amplitude profile along depth direction, and the mode index 2.205833 along depth direction. This is the flow chart of my computation. Finally, theoretical approach. Or theoretically, we get this result. We have considered the two coordinate systems. One is fixed at the scanning laser beam. Another is fixed to the lithium niobate. Actually, when lithium niobate is exposed by the UV laser, lithium is a live material. It absorbs heat and indiffusion take place. At the indiffusion, increase the extraordinary diffractive index in the exposed region, which guided the wave by total internal reflection. So it can be used the waveguide. There is a two frame of reference: the scanning laser beam in the frame of reference capital X, capital Y, capital Z, and the fixed frame is attached to the lithium niobate, which is expressed in small x, small y, small z. The heat equation is expressed in equation 5, where dt is depend on temperature. So the equation is non-linear, and to make it linear, we use Kirchhoff transformation. Finally, using Kirchhoff's transformation, we obtain the equation 8, where S is the source term containing alpha. Alpha is the absorption coefficient. Most of the researchers assume alpha is a constant, but in our model, we introduce alpha is the temperature dependent term, which explain the formation of UV written waveguide, which able to explain the formation of UV written waveguide. Finally, using the diffusion equation, which is written in equation 11, we obtain the concentration profile. Then using Selmayr equation, we obtain the refractive index profile. Selmayr equation is written in equation 13. Computation procedure from experimental published data, we fitted the equation and obtain a relation absorption coefficient which depend on temperature, written in equation and 14. At first we obtain the temperature profile. We use the finite difference technique explicitly, and use equation 15. We obtain temperature profile, and hence we obtain the using diffusion equation, using finite difference technique, we obtain the refractive index profile. From introduction of temperature dependent absorption coefficient, there is a huge change of temperature. If we consider the alpha is a constant, 3.71 into 10 to the power 4 per meter, then temperature rise is 90 degree, which is represented in figure B. But if we introduce our temperature dependent term, then huge change of temperature, that is nearly equals to melting point 1257 degrees Celsius, which enable to explain the formation of waveguide, which is experimentally support this model. Finally, we obtain the refractive index profile along lateral direction and depth direction. The blue color indicates the concentration profile, red color curve indicates the extraordinary refractive index change. But from this figure, we observe that full width hub maxima is nearly about 1.5 micron, which is not experimental support. That is very small compared to the experimental result. We have to obtain the actual full width hub maxima, optimizing the parameter activation energy. In thermal diffusion equation, there is a one term R. R can be written as R0 e to the power minus Q by KT. Q is the activation energy. Now we consider optimize the Q 1.3 eV, which enable to explain the actual refractive index profile. Or red color refractive index profile is the experimental result, and blue color curve indicates the theoretical result, which is fairly good. So our model enable to explain and the formation of UV retin waveguide at 305 nanometer writing wavelength. Finally, we discuss the conclusion. The design process can be used to fabricate efficient waveguide electro-optic devices without lithography. Inclusion of temperature dependent absorption coefficient to determine the refractive index profile, optimization of activation energy to validate the refractive index profile, the estimated refractive index profile and contrast 305 nanometer UV retin waveguides is the excellent agreement and data excellent from the measure mode profile. To fabricate waveguide leads to believe the thermal diffusion of lithium ion. That's all. Thank you.
Let's all thank Dr. Ghosh for such a wonderful presentation. And with this, we have almost reached the conclusion of, or the end part of the talks for the last 2 days. We have observed so far 18 talks out of 19. One talk we could not make possible because of some internet issues. Dr. Gajendra Almighty will not be able to join with us because of internet connections. So yeah, that's a problem we can't solve.
Excuse me, I am Sushi Dutta.
Yes, ma'am.
Excuse me.
Yeah.
Can you hear me?
Yes, ma'am. We can hear you.
I was disconnected during the talk, and
would you like to continue?
Can you represent again?
Yes, we can give you 2 minutes, ma'am.
Yes.
We are actually running short of time. Please start and finish it 2 minutes, please. Okay, everyone, please listen to Dr. Sushi Dutta. She will start from where she left with us.
My article focuses on the performance of silicon solar cell with incorporating nanoparticles that we use to distinct approach either by changing the size of the active amorphous silicon into nano formation or incorporative nanomaterial combined with the amorphous silicon in hybrid solar cell. Here, the hydrogenated nanocrystalline silicon solar cell, actually it is called the hydrogenated microcrystalline silicon thin film, and it is composed of amorphous phase and a few nanometer size crystalline silicon grains are embedded there, and this is the deposition table that how nanocrystalline silicon hydrogenated films were prepared by changing the higher hydrogen dilution. And this is the properties of nanocrystalline silicon thin film, and the properties are the thin film has high optical band depth around 1.1 electron volt, and its light induced degradation is also low, and nanocrystalline silicon thin film has lower optical band gap and higher absorption coefficient of longer wavelength. So P-type nanocrystalline hydrogenated silicon is also as a promising material for solar cell window layer. It can also used as the bottom cell of a multiple junction solar cell. Actually, this is the schematic diagram of single PIN type double junction and triple junction solar cell, where the nanocrystalline hydrogenated silicon is incorporated here, and we say that the performance of amorphous silicon and nanocrystalline with amorphous crystalline tandem solar cell. Here we see that the efficiency of amorphous silicon solar cell is 10.22%, where the amorphous silicon combined with the nanocrystalline silicon thin film rises the efficiency 12.69%. And this is the structure of a heterojunction intrinsic thin layer, where ARC used here. The here is the anti-friction coating. The pyramidal structure of AC is replaced by nanowire arrays or nanoparticles that enhances the light trapping and increases the current. This is the pyramid type textured silicon solar cell, and this is done by Chen, which shows that the efficiency increases 16.5%. And here we see that the nanomaterial used as an alternative of P-type transparent conduct window layer in combination of single wall carbon nanotube amorphous hydrogenated silicon solar cell achieved a record power conversion efficiency 8.8%. This is the basic architecture of hybrid solar cell. Here the P-type is replaced by the single wall carbon nanotube, and this efficiency is 8.8%. This is the year-wise efficiency of different types of solar cell, and we see that the crystalline silicon till rises around 25%, whereas in the case of amorphous silicon it is stuck around 10%. And this is the comparison between different types of solar cell. Here the fabrication cost of crystalline silicon solar cell is high and the efficiency is also high, whereas in case of amorphous silicon solar cell the fabrication cost is low and efficiency is also low. This is my conclusion. Due to lower conversion efficiency, the practical applications of amorphous hydrogenated solar cell is very limited. We expect that recently developed new material combined with amorphous hydrogenated silicon, that is the new material means organic material, perovskite or nanomaterial instead of transparent conducting oxide, will increase the conversion efficiency nearly to 25% in future, and will keep the market in solar cell industry. Thank you.
Okay, let's all thank Dr. Ushashi Datta for her wonderful presentation. So with this, we have we have concluded all the talks which we were waiting for the last 2 days. So in these 2 days, we could observe and hear 18 talks out of the 19, as I already mentioned. One talk was not possible because of some internet issues, but yeah, we can't do anything about that. So we'll go into the last session.
Stop sharing the click करो तुम्हें ऑडियो लगा ऑफ कर देना.
Abradit, please unmute yourself.
Oh, sorry. So we could, in these 2 days, we could observe or we could hear 18 talks out of the 19. One talk was not possible because of some internet issues. But anyway, we still could make this impossible possible with our limited resources. And the mastermind behind all of this was the president of this webinar as well as the principal of our college. So we'll go into the valedictory session and the presidential address by our principal, Dr. Anupam Parua. We are really thankful to him, and because of its enormous amount of enthusiasm and his direction, we could make this possible. He has always been an immense source of inspiration for all of us. He has been a true leader during the time of execution. He has showed us the path, and during the time of the celebration, he has always stood behind us. So ladies and gentlemen, please welcome the president of this webinar as well as the honorable principal of our college, Dr. Anupam Parua. Sir, over to you.
So we are at the very end of the today's very interesting and very successful webinar, RTNN. So before signing off, as the president of this organizing committee, I cannot resist myself to share some of my views regarding the general conduct of the seminars. First of all, being organizers, we should try to have a topic which is having recent trends, interest in the recent world, covering some issues which the mankind needs in the current situation. Like nowadays we are facing the pandemic called COVID-19. So the field of studies which can have some light on the issue should have come forward to have webinars on the very topic. So we are from different other disciplines, so we cannot have any direct impact on that. But thank you organizers for making this seminar on a topic which is a trendy one. Now come to the researchers. The researchers should be thinking of a seminar not within the theoretical pronunciation and ideas, but beyond that. They should think of writing something, having a proper research work behind it, so that it can truly benefit the mankind. Just mere research, having certain pages written, will not do. So as a researcher, I feel it in this way. And now the connectivity between the organizer and researcher. So as I have already mentioned, the organizers should have chosen a topic which can encompass not only a particular discipline, but also certain other allied disciplines. So they should have some interdisciplinary approach in their mind. And at the same time, researchers should have the feeling that they are to make some valuable research so that they can really contribute to the world of knowledge in their particular field. And another thing I would like to point out is that there should be a linkage between the researchers and implementers, which to my mind is missing in India, in our country like India. So whenever the researchers found something, and if their finding is valuable, then the governmental mechanism should be there so that that research finding can be taken up for future benefit of mankind. Otherwise, just writing paper, publishing it in journals or books will not do, will not serve the very purpose of having good quality research work. So the government and government agencies should come forward with that kind of idea so that all the research works are really taken seriously. They should have the mechanism to value the research work seriously so that good quality researchers can come out with their newer ideas, and that newer ideas can only solve the problems of mankind, the problems that are faced by mankind. So that is my humble submission to all the researchers, so that the future researchers, like the young researchers like Abradit or Arif or Shreyoshi, all can understand what I am saying. So before signing off, I am duty bound to congratulate all parts of the organization of the seminar, all the paper presenters, all the resource persons who were in the seminar in different capacities, and all the persons who provide the valuable support system so that we can organize such a seminar. As I have mentioned in my earlier session, that sitting in a village area, it was not that easy to organize such a webinar at that scale and level. And you people have made it possible, and I congratulate you all for that. And being the president of the seminar, I personally thank all of you for the organization of the seminar. And by saying that, I am signing off. Thank you all.
Thank you, sir, for such a wonderful address to all of us. Really, your inspiration and your coordination, your advice will be always with us. That's our expectation, and we are bound, and we are hopeful. We are expecting that we will keep your expectation up to the level. Now we are absolutely at the end part of the 2 days long webinar. So it's the vote of thanks, and in order to conduct the vote of thanks, or in order to deliver the vote of thanks, I would like to invite the Secretary of the Teachers Council of our college, Dr. Rajashree Devnath. So ma'am, please come and deliver the vote of thanks, please.
Thank you, Abru. Could you hear me?
Yes, ma'am, we can hear you.
Okay. Very good afternoon, everybody. It gives me immense pleasure to deliver vote of thanks for this 2-day international webinar on recent trends in nanomaterials and nanobiomaterials organized by the Department of Physics, Narajole Raj College. On behalf of the Teachers Council of Narajole Raj College, I would like to thank first of all our beloved principal, Dr. Anupam Parua, for his constant guidance, motivation, and also inspiration thought. Thank you, sir. I would like to express my sincere thanks to the eminent invited speaker of today's program. The first speaker, Dr. Sudipta Pal, Scientist, Department of Innovation Engineering, University of Salento, Nice, Italy. Thank you, sir, for your wonderful presentation on nanomaterials in environmental remediation, self-cleaning, and antibacterial surfaces from laboratory concept to practical application. This was a wonderful presentation, and I think it will enrich everybody and even laymen like us. The second speaker, Dr. Haradhan Kole, from Postdoctoral Fellow, Department of Housing, Environmental Design and Research, Jeonbuk National University, Republic of Korea. His presentation was on metal nanostructure for wastewater purification. Was a nice presentation, and I thank both of you, sir, for your joining us in spite of your busy schedule. Thank you, sir. Today we had 10 young enthusiastic scholars from all over West Bengal, even from India. They have presented papers and through highlighting different areas which invoke the curiosity of the listeners. They are Mr. Bapashuna Kor from Bonamali College, Dr. Kalipodo Makura from Tamolipto Mahavidyalaya, Dr. Sweety Jain from Shamrat Ashok Technological Institute, Madhya Pradesh, Dr. Amit Kumar Bhuya and Devashish Attu, both from Government General Degree College, Dr. Shoma Sundar Moti of Government General Degree College, Kharagpur, Dr. Kaushik Chandra from Mindapur College, Dr. Gajendranath Maiti from Ashutosh College, Kolkata, Dr. Ushashi Datto and Dr. Taposh Ghosh, both from Jhargram Raj College. Thank you all for sharing your fresh academic thoughts with us. Now I would like to thank our most efficient, sincere and dedicated members of Technology Committee, Dr. Sheikh Mohammad Aziz, Professor Borun Raut, Professor Abhudip Pradhan, Professor Shreyoshi Jana, Professor Polomi Odhikari Mukherjee, Professor Tanmoy Goswami. Without their solid technical and technological support, this webinar could not be so smooth and excellent one. Thank you, everybody. My special thanks to Dr. Tapanendu Kamilla for organizing a truly international webinar in such a difficult time. Thank you so much for taking such academic venture and materialize it successfully. Thank you. My very, very big thanks to Abhudi Pradhan, one of our youngest colleagues, for his knowledge and excellent management and coordination for this two-day international webinar. I would like to thank Professor Dr. Nilanjana Bhattacharya, the coordinator of IQC Narajole Raj College, for her overall supervision, never-ending enthusiasm and inspiration. Thank you. I must acknowledge the contribution of the entire team of Department of Physics, consisting of Dr. Tapanungu Kamilla, Dr. Abhudi Pradhan, Professor Arif Iqbal Malik, Professor Surojit Dhara, and Professor Umanto Haid, and of course, Shisupal Barik for their contribution. The publication team needs special mention. Thank you, Arif, for your work. Finally, my very, very big thanks to all you dear participants from our college and our institutions too. I know I stand between you and lunch, so no more delay. I would like to thank each and everybody associated directly and indirectly with this mind-blowing academic venture. Thank you. Over to Abhudi.
Thank you, ma'am, for your vote of thanks. So it's time to conclude the webinar. I would like to thank all the listeners and the audience to make this two-day-long webinar a successful one. Now it's time to say goodbye. From on behalf of the Department of Physics and Narajole Raj College, I'd like to bid you goodbye. My wish is you stay well and stay safe during this pandemic situation. Stay healthy and stay happy. Goodbye to all of you. Just before I sign off, only one small announcement that those who are looking for or interested for the feedback form and those who haven't filled the feedback form given in the chat room, that will be given in the WhatsApp groups which you have registered in very soon. So please fill that form and let us know how you felt about this 2 days long webinar. So that's from me. Stay happy and stay safe. Thank you.